subtraction of the vectors. Okay, subtraction. So vector subtraction. So in case of addition, what we have done, suppose this is vector A, and if you want to add, and this is vector B, so how we can add? Simply use the triangle of vector addition, that is what, draw the first vector as it is, then join tail of second vector to the head of first vector. So this is what going to be, vector should be in a straight line. So this is what the vector B. So what will happen if you join them? If you join these two vectors, and one more important condition is what? In the opposite order. These two are in same order, means same direction. So we have to take in opposite order. So this is going to be what? A plus B. So we can simply add it. Then question arises, suppose if I want to make it A minus B, suppose A is here, this is vector A, so minus of say vector B. So what you want? You want vector A minus vector B. So what will be the vector A minus vector B? So remember, there are no other laws separately for the subtraction. Again, we can use the triangle of addition only to subtract also. But what we have to make, we have to take care that the resultant should come what? It should come A minus B. Remember, we are going to add only, but resultant should be what? Resultant should be A minus B. So how we can do that? Okay. So just follow up your vector law of addition. Take the first law. Sorry, first vector A. So this is what? Vector A. So take it as vector A. Then where is vector B? This is what the vector B. So this is what vector B. Okay. So if you take resultant here, that is going to be what? That is going to be A plus B. But what do you want? You want A minus B. So in place of plus B, what is required? It is required that minus B is required. So how we can get minus B from the plus B? That is what we call it as a negative of the vector. Okay. So if you have vector A in this direction, so what is the negative of vector A? Negative of vector A is, it is in this direction with the same magnitude. Magnitude of vector A is equals to negative of magnitude of vector A, but direction will get changed. Okay, that is what we have discussed. That is what we call it as the negative of a vector. Okay, so negative of vector. So same thing we are going to use here. Okay, so in place of B, what is required? Minus B is required. Minus B is nothing but same vector B, but in opposite direction. Magnitude is same, but direction is opposite. So I will take it here. So this is what minus B. Okay, this is what minus B. Now forget about this one. No need to think about this B now. Think of this one. So apply vector law of addition again. So how we can apply here? These two are in same direction. So resultant should be what? Should be in opposite direction. So this is what going to be your resultant. Okay. So this is what. So this is what going to be your resultant. So what is this one? This is nothing but vector A. Listen properly. Same direction. So this is in opposite direction, opposite order. Vector A plus, this is what? Minus of vector B. Getting it? I am not actually subtracting, I am just adding only, but instead of adding B, I am adding minus B, means negative of vector B. Okay, so this will become what? This will become A. So plus minus will become what? Minus. So minus B. This is what subtraction of vectors. I am not using any other, I am using same vector law of addition only, but I am taking, instead of B, I am taking minus B, negative of vector. So what is this one? This resultant is nothing but vector A minus vector B. Vector A minus vector B. So this is how we can get the vector A minus vector B. Okay. So what law we are going to use again? What triangle law of vector addition? You may ask then, what about the if vectors are like this, if their tails are joining at a point? So how we can do this one? So this is what, say this is vector A and this is vector B. Okay. If this is the case, so where will be the or what is the A minus B? Again, if they are asking A minus B. So this is the case where we can connect two vectors head to tail. But here it is not possible to connect them head to tail. If this is the case, how we can add these vectors? We can add these vectors with help of what parallelogram law of vector addition. So how we can do that one? So just we will take it here and it will become a parallelogram. So this is what going to be. This is what going to be vector A plus vector B. Okay. So this is what addition. But you don't want A plus B. What you need is you need A minus B. Okay, so if this is the case, so what I have to do is take vector A as it is. So take vector A. So this is here. So this is what vector A. So where is vector B? This is what vector B. Okay. Now what you have to do? Instead of taking vector B, take negative of vector B. So where is negative of vector B? So this is what negative of vector B. So this is what minus B. Okay. So now again use the same parallelogram law. So just you can join it. So make it a parallelogram. Okay. So this became a parallelogram. So where is the resultant? Resultant is going to be this one. So your resultant of A minus B is going to be here. So this is what the resultant. So again what I have done, vector A plus of minus vector B. So that will become what? Vector A minus vector B. So this resultant is nothing but what? This resultant is nothing but vector A minus vector B. Okay. So this is what how we can calculate the vector subtraction of vector or subtracting two vectors when they are given two vectors which may be joined from head to tail or which are joined tail to tail. Okay. So suppose if I have vector A over here and vector B over here. If I want vector A minus B, what I will do? This is what vector A. This is what vector B. So what I will do is I will take B over here. So that will become what? Minus B. I will join this one. So this will become what? In this direction, means opposite direction. So this is what? Vector A minus vector B. Now you may ask, sir, what if I want vector B minus vector A? How we can find the vector B minus vector A? Same thing you can follow here. So first you draw vector B. So this is what the vector B. So where is vector A? Vector A is here. So vector A is here. So this will give you what? This will give you vector B plus vector A. This will give you vector B plus vector A. But what you want? You want vector B minus A. So in place of plus A, what is required? Minus A is required. Okay. So this is what vector B. This is what vector B. So what is required? A is in this direction. So minus A is opposite to this one. So minus A will be here. So this is what minus A. Okay. So where is your resultant? So resultant will be in this direction. Okay. So it is in same order. So the resultant will be opposite of it. So this is what vector B minus vector A. So this is what vector B minus vector A. So no need to draw this B. Just to draw minus B. Okay. So I am not drawing A over here. So just I am drawing minus A. So if you want to draw, so this will become what? This is what your vector A. So not required. What you want is minus of vector A. Okay. So negative of vector A. So this is what B minus A. So like this you can get. Suppose 4 minus 3 you will get like this. So 3 minus 4 you will get in opposite. Okay. So sign will get changed. So that is why directions are changing. A minus B is in this direction. So B minus A is in this direction. 4 minus 3 is 1. So 3 minus 4 is minus 1. So signs are what? Signs are opposite. So that is why direction of vector is coming what in opposite direction. Okay. So that is what a minus b or b minus a. So same thing will happen if you use the parallelogram law of vector addition also. Suppose you are having say two vectors. So this is what vector a, and I will take one more vector here. This is what vector b. So take vector a plus b. Vector a plus b will be here. So vector a plus b. So vector a plus b. So vector a plus vector b. Direction is in this direction. So this is what the direction. Opposite to this one. They are in clock anti-clockwise. So this will come in clockwise. Okay. So if I calculate the a minus b for the same, if I want to calculate a minus b, so take minus of or negative of vector b. Negative of vector b will be here. So this is what the negative of vector b. So this is what minus b. So now calculate vector a minus b. Okay. So this is what vector a minus b. So this is what vector a minus vector b. Vector a minus vector b. So now vector a plus b is this one. Okay. What about vector a minus b? Not exactly this much length. Length is also different, direction is also different. So a minus b will be here. So this is what vector a minus b. So if you look at these two, you can easily understand that vector a plus b is not equals to vector a minus b. So vector a plus b is not equals to vector a minus b. Why? Because magnitude also different and direction is also different. Okay. When we can say two vectors are equal, or when resultant is equal, when they have same magnitude and direction, then we can say those vectors are the equal vectors. So now these are not equal vectors. Magnitude, length is also different. Direction is also different. Okay. So that is why this is important to remember. Vector a plus b will never be equals to vector a minus b. Now we can. I will take one more example. You will be surprised. So I will take this as vector a. At right angle I will take vector b. At right angle I will take vector b. Okay. So what will be the a plus b? A plus b will be here. So a plus b will be here. So this is what a plus b. Okay. So this is what a plus b. Vector a plus vector b. Okay. So what is a minus b? So a minus b will be in this direction. So same length of it. So this is what minus b. So resultant will be here. Okay. So this is what is the resultant. So vector a minus of vector b. Vector a minus of vector b. Okay. So if you look at here, one resultant is going here, another resultant. This is what a plus b. So here what a minus b. Okay. So if you look at this diagram, when angle is 90 degree, when they are perpendicular to each other, the length of a plus b is equals to length of a minus b. The length of a plus b is equals to a minus b. But direction is different. If direction is different, we can't say. So we can't say they are equal. So what we can say, a plus b is not equals to vector a minus b. But magnitude, if we consider only length, but their magnitudes are same. If we take a magnitude, so if we take magnitude, so magnitude of vector a plus b is equals to magnitude of vector a minus b. This is possible only when theta is 90 degree. If you take this one here, magnitude is also not the same. A plus b is not equals to vector a minus b. Here magnitude also not same because it is coming in this direction. So obviously this length will be less than this one. But here, so when theta is 90 degree, their lengths are same. If you apply Pythagoras theorem here, if you take 4 and 3, 4 the square plus 3 the square, if you take square root, it will become what, 5. Again this is what, minus 3, and this is what, 4. 4 the square and minus 3 the square, it will become again what, again root of 25, so that will become what, 5 again. Okay, so lengths are going to be same, but their direction are different. So if you take simply vector a plus b is and vector a minus b, they are not equal. If you take magnitude, if you take their length is going to be same. Possible only when theta is 90 degree. Otherwise, remember vector a plus b will never be equals to vector a minus b. That is what we show it on the board. Very important method, that is what we call it as analytical method. Okay, so analytical method. Okay. So what is this analytical method? So whatever so far we have used, that was the what, graphical method. Suppose if you know this length and this length, so join them, take a scale and measure, you will get the answer. So for that, what small scales can be done with help of this one. Suppose if the problem is something like this, so rain is coming in this direction with some velocity and the person is running in this direction, so in which direction you have to hold the umbrella. So if that is the case, you cannot take a scale and then measure and then hold the umbrella. By that time you will be wet. Okay. So that is why it is not possible to measure or use the graphical methods here. So these all are what graphical methods. So if that is the case, if you know the velocity of wind blowing and what is the velocity of air, then you can calculate yourself and hold the umbrella, so you can save from the water. Okay, so or you are crossing the river and river flow is in some direction. Obviously, you will not reach this in the exactly opposite. So somehow you will go in this direction. So with what velocity you will go, or how much distance you will go far away from your destination. So all those things you cannot use the scale. You cannot use the scale and measure what your river or something. Okay. So graphical method fails in some cases. So that is why the analytical method is very important. So that is what we call it as the analytical method. So from the analytical method, how we can find the resultant of a plus b or a minus b. So that is what we are going to discuss today. So with the help of analytic method, so if you have the vector a over here, so and vector a going like anything, so vector a plus take this as vector b. Okay. So if this is the case, so see properly. So both if this is the vector a, I will draw it here. This is what vector a. Okay. So now vector b will be here in this direction. Okay. So this is what vector b. Now you want a minus b, a plus b. If you join it is okay, but if it is very long, if it is the magnitude is very high, then this method of joining will not work. Obviously resultant will come here only, so that will not go anywhere. So resultant will come here only, so that is not a problem. So this is only going to be a resultant, so I will write resultant as r, that is what a plus b. So r is what? R is vector a plus vector b. This is what we want. So how we can find this one? So this point I will take as O, and this I will take as some P, this is some Q. So I will extend this vector. So listen properly. Derivation is also important. And I will join this here exactly perpendicular. Okay. So this will be what? This will be 90 degree. This will be 90 degree. PQ I will take this as R is already there. So you can take this as S. Okay. So if this is the case, so how we can find the resultant? What you need is you need R, okay, by analytical method, okay. So for that, take this as some theta angle. We don't know how much, but you can take it as theta angle, okay. So if you take this as angle theta, so take only this triangle. You take only this triangle. So you take only that triangle. So what is that triangle? This triangle is nothing but PQS. Okay. So PQS. This is what? This is theta. Okay. Now, if you know this as B, so if I take this as B, okay, or you can take PQ. So how we can find this? How we can find PS? If you remember cos theta. What is cos theta? Cos theta is adjacent divided by hypotenuse. What is adjacent? Adjacent is PS divided by hypotenuse. Hypotenuse is PQ. So PQ. What you need? You need PS. What you need is PS. So PS is equals to, take PQ on this side. PS is equals to PQ cos theta. What is PQ? PQ is nothing but vector B. So I will write it as vector B cos theta. Okay. So this is what vector B cos theta. What is that? PS is equals to B cos theta. So PS equals to B cos theta. Shall I write it as B cos theta? So this is vector B cos theta. Okay. So what about this one then? You need Q in QS. So to find QS, consider sin theta. So sin theta is QS opposite divided by hypotenuse. Opposite is what? Q into S. Q into S divided by, QS divided by PQ. Divided by PQ. So what you need is you need QS. So QS is equals to PQ sin theta. PQ sin theta. So what is PQ? PQ is nothing but B. So B sin theta. So B sin theta is going to be what? B sin theta is going to be your QS. So this is what? B sin theta. So B sin theta. This is B sin theta and this is what? B cos theta. Let me write in B sin theta. Okay. So now I will consider this whole triangle. Now I will consider this whole triangle. So what is that whole triangle? So this is what the whole triangle. So this is there. Then we have done this one. So from here some dotted lines are there. So this is what your resultant. So this is what R, vector R. This is what O. This is what Q. This is what yes. Okay. See here now. This is so 90 degree. Okay. This is not theta. This is not theta. This is theta, but this is not theta. Okay. So don't worry about that one. From here to here, how much it is? From here to here, it is A. Okay. So from here to here, it is B cos theta. So total is what? A plus B cos theta. Okay. So total you can write. From here to here, it is A. Here to here, it is B cos theta. Okay. So total is what? This is A. This is B cos theta. So total will become what? Vector A plus vector B cos theta. Vector A plus vector B cos theta. What is this one? This is nothing but B sin theta. This is nothing but B sin theta. This is to R already there, so no need to worry about that one. So how we can find this R? So how we can find this R? So now you have to take only magnitude. You cannot use the direction. You have to find direction separately and magnitude separately. If I take magnitude, so this will become what? A plus B cos theta, and this is what? This is B sin theta. So this is what? B sin theta. Okay. So directly I can take that only. This is what? A plus B cos theta. A plus B cos theta, this is what B sin theta. Okay, so now if this is the case, so apply your Pythagoras theorem to find the R, to find the OQ. Okay, so from Pythagoras theorem, from Pythagoras, okay, Pythagorean, from Pythagorean theorem. So what you can write? OQ square is equals to what you can write? QS square or OS square, QS square plus what you can write? First you take OS square plus QS square. Okay, so QS the square. Okay, so what is the OQ square? OQ square is nothing but R square is equals to, what is OS? OS is A plus B cos theta. So A plus B cos theta the whole square plus what is QS? QS is B sin theta. QS is B sin theta. Okay, so sin theta square is the square right as it is. Okay, so R square is equals to A plus B the square. A plus B the square. What you can write? A plus B the square. So shall I write it here? I will write it here. A plus B the square is equals to A square plus B square plus 2AB. Okay, apply here. So A square plus B cos square theta. Okay, so B square cos square theta plus 2AB cos theta plus this you write as it is. So B square sin square theta. B square sin square theta. Okay, so R square is equals to you write A square as it is plus you make B on one side. Okay, this is what B square cos square theta, B square cos square theta plus this is what B square sin square theta plus 2AB cos theta. Okay, so R square is equals to A square plus B square will take outside, so what remain inside is cos square theta plus sin square theta. Cos square theta plus sin square theta. If you take B square outside, so plus 2AB cos theta. Okay, this is what left with us. So now R square is equals to A square plus B square to write as it is. What is cos square theta plus sin square theta? Cos or sin square theta plus cos square theta or cos square theta plus sin square theta. Anything you can say. Sin square theta plus cos square theta is equals to 1. Remember this, you must have gone through this one in your trigonometry. So cos square theta plus sin square theta will become what? 1. So no need to write 1. So plus write as it is 2AB cos theta. 2AB cos theta. This is what your resultant. Resultant means only magnitude. So R square is equals to A square plus B square plus 2AB cos theta. But you don't want just R square. You need R. So R is equals to square will become what? Square root. So square root of A square plus B square plus 2AB cos theta. A square plus B square plus 2AB cos theta. This is what going to be resultant, only magnitude. This is not a direction. This will give you only magnitude. So this is nothing but magnitude of R. So this is only magnitude. So this is only magnitude. So magnitude is equals to root of A square plus B square plus 2AB cos theta. Magnitude of resultant, but vector means what? We should tell both direction and magnitude as well. Okay, so direction, how we can find direction? If this is the horizontal line, how much angle it is making will tell you what direction. Okay, so you take this angle as some whatever you can. You take alpha, you can take beta, gamma, whatever you can take, or you can take simply m, n, whatever you can take. Okay, so this angle I am taking it as alpha. Okay, So how we can find this angle? So to get this angle, I will write it as you can take sin theta, cos theta, tan theta, whatever. If I take sin theta or cos theta, hypotenuse will come. If hypotenuse will come, it will be complicated. So better if I take tan theta. So from this triangle, tan theta means what? Opposite divided by adjacent. So for direction from triangle OQS, tan theta is equals to QS divided by OS. Okay. So tan theta is equals to, what is QS? QS is B sin theta divided by, what is the OS? OS is A plus B cos theta. Okay. So this is what going to be direction. So direction, that is vector R direction, that is alpha. So direction of vector R is tan, not theta, alpha it is. Okay. So theta is different, alpha is different here. Theta is what they are given, alpha is what you are finding. Okay. So tan alpha is equals to B sin theta divided by A plus B cos theta. Remember, very important result. These two are very important. This one and that. Okay. So whenever they ask you to find the vector with the help of analytical method, you have to find both vector R. First you have to find magnitude of vector R, that is square root of A square plus B square plus 2AB cos theta. Then you have to find direction as well. Direction means how much angle